Namaste, welcome to Pythagoras Academy. This is Vikram DACHEPALY. In this video, I'll try to clear a big misconception about electric field and conductors. People who are preparing for JEE or NEET might have encountered this statement in the chapter of electrostatics in several books that electric field inside a conductor is zero. But I would say this is not a right statement. This is not the right way of understanding the property of a conductor, because this violates the concept of current electricity. For example, if there is a conductor and the ends of the conductor are connected to a battery, there is definitely electric field developed inside the conductor, due to which the charges experience force and they get accelerated and they start moving. So all the charges would gain an average velocity of drift velocity. That average velocity is known as drift velocity. Due to that drift velocity, there is electric current passing through this conductor. So there is electric field inside the conductor in this case. So there is a basic flaw in this statement. Basically, this statement is not meant for a conductor carrying a current. So the right word is a stable conductor. So let me modify this statement as electric field inside a stable conducting material. I would like to add another word, that is material, is zero. This statement is complete. Electric field inside a stable conducting material is zero. What is a stable conductor? If there is no flow of charge inside any conductor, that is known as a stable conductor. In this example, this is an unstable conductor. A current carrying conductor is unstable conductor. That is the reason why there is electric field. If it is a stable conductor, and that too inside the conducting material, not just inside the conductor, that electric field is zero. Let me explain this concept. Consider a conducting slab. This is a conducting material, for example, copper. And say an external electric field is applied to this conductor. Because this is a conductor, there are free charges inside it to move. If I take copper as an example, electrons are free to move. If you take any electron, it is experiencing force of E times capital E. So due to this force, the electrons can move and they accumulate at this end of the conductor, leaving the positive charges here. You can see the polarization effect developed because of the external electric field. So there is an induced electric field EI created. Now any electron inside this conductor is experiencing the net force of E times E and E times EI in the opposite direction. The net electric field is E minus EI. Applied electric field minus induced electric field. Of course, initially the applied electric field is higher and induced electric field is zero. So this is zero induced electric field. Applied electric field is somewhere here. And as long as this E is greater than EI, the charges will experience net force towards left, and the charges are getting more and more accumulated at the left end, increasing this induced electric field. So what happens is this induced electric field goes on increasing. At one point, induced electric field becomes equal to the applied electric field. At one point, EI is equal to E. That is when the net electric field inside this material is zero. Until then, until net electric field inside the material is zero, the charges move. It is unstable conductor. So the property is not violated. Because it is unstable conductor, there is net electric field. Once net electric field becomes zero, because induced electric field goes on increasing, at one point definitely it should match E. Till then the charges will flow. And once the net electric field is zero, the net force on any charge is zero, then there is no more mobilization, there is no more movement, there is no more polarization. It stops there. So the conductor has become stable. Once the conductor is stable, you can observe net electric field is zero or vice versa. So it is a property of a stable conductor that inside the conducting material, that net electric field will adjust to zero. Even if you subject the conducting material to very high electric field, the charges inside the conducting material will move in order to make the net electric field inside the conducting material 0. Why am I using the word material? Because there is another possibility that this is conductor. So this is all conducting material and there is a cavity inside the conductor. So this portion is cavity. This is all conducting material. I'll choose a point A and point B. Point A is inside the conducting material precisely, whereas point B is inside the conductor, but there is no conducting material at point B. Point B is inside the conductor but not inside the conducting material. I can say, no matter what, you subject it to external electric field or you take it anywhere, no matter what, net electric field at point A is 0. This is a stable conductor because it belongs to conducting material. And at point B, I cannot say it is 0. It may be 0 or may not be 0. It depends. We have to check. We have to check whether there are any charges inside the cavity. If there are any charges inside the cavity, yes, there is a possibility of electric field to exist within this cavity. So there can be electric field inside the cavity of a stable conductor. But no matter what, inside the conducting material, it is always 0. So this is the right way to understand the property of a stable conductor. That's all. If you have any questions or suggestions, you can always use the comment section to interact with me. I'll be more than happy to help you out. This is Vikram DACHEPALY signing off. Namaste.